Okay, now we're going to look at the range of secant and cosecant functions. I'm going to tell you right now that it's going to be similar to sine and cosine, not the same, but related, and that's obviously because secant and cosecant are related to cosine and sine respectively. So let's go ahead and take a look at some graphs. First graph we're going to look at is cosecant. We've seen this plenty of times before. We have a bunch of upside down U's on the bottom of the graph. Now I want you to notice where they stop. They stop at -1, right? And there's a gap here. And then the right side up U's begin at 1 and they go to infinity. So what's the range of this graph? It goes from -infinity up to -1, stops, and then starts at 1 and goes to infinity. Remember, you can take like a ruler or something and just scan up like this from bottom to top to figure out what the range is. So we're going to go ahead and think about what that means in terms of amplitude and the d value, which is the vertical shift. Let's go back to the graph. So in this case, we're looking at cosecant. We can see that d is 0 because it's just cosecant of x. So the middle of the graph is at 0, right? Now, secant and cosecant don't have amplitude, all right? Neither do tangent and cotangent, but they do have an a value. In this case, a is 1. So can you see that if you take the a value and subtract the your d value, if you take the d value and subtract a, so d0 minus 1, you will get this number right here. Okay, it's not the start of the range, but it'll go from -infinity to d minus a, right? And in fact, more specifically, it's going to be d minus absolute value of a, because even if a is -1, okay, it would still go up to d minus a. Let's remove the parent function. It would still go up to d minus absolute value of a. So we're not going to call it amplitude, we're just going to call it absolute value of a. Okay. Actually, we will call it amplitude. Why not? Actually, you know what, let's change this, because I mean it's close to being the amplitude, but it's not quite. It's the absolute value of a, which I realize is the amplitude for sine and cosine, but we'll just keep it that way. But I want you to see that this looks just like sine and cosine, okay? We know the range of sine and cosine go from d minus amplitude to d plus amplitude. The difference here lies in that gap in the way the u's are. So we're going to go from -infinity to d minus amplitude, and we're going to include that second part right there, and then we're going to go bracket d plus amplitude, and we'll go to infinity. Okay, and that's going to give us our range. Going back to the first example, if we crunch the math, this would give you -1, so -infinity to -1, and then 0 plus absolute value of 1 is 1. So let's see if this gives us the range. -infinity to -1, I need a bracket there. Okay, -infinity to -1 bracket, and then bracket 1 to infinity, given this formula. So does this work? -infinity to d minus absolute value of a, bracket d plus absolute value of a, infinity. Does that give us the range? I know it's a mouthful, and this is definitely the hardest formula to remember. But yes, that does work. It goes from -infinity to -1, bracket, because it actually touches there, and then it goes from bracket 1 to infinity. Let's look at some more examples. Okay, let's make a equal to 2, and we're going to keep d at 0 and see what happens to the range. Okay, and I'm actually going to slide d around a little bit just so you can see what happens. It moves further and further away from the middle. But let's go to 2. And we do indeed see that, again, that we're going to call these vertex, even though they're not really parabolas. This vertex right here is going to be at d, which is 0, minus absolute value of a. So d minus 2. So 0 minus 2 is -2, and then 0 or d plus 2, 0 plus 2, is going to be the bottom of these parabolas. Again, they're not really parabolas, but they look like it. And so that just further shows us that this is going to give us the formula for the range. Again, I know it's kind of complicated. So the range for that graph is -infinity to -2 bracket, and then bracket 2 to infinity. Let's look at another example. Okay, so I'm going to do this one a little bit different. I'm going to make d2, and I'm going to keep the amplitude at 1. And we'll just keep going. So let's make d equal to 2. and we'll make the amplitude 1. Okay, so we can see that the graph shifts up 2 units. Here's what it looks like at 0. Shifts up 2 units, right? Nothing happens to the amplitude. So again, we can see the amplitude is going to be 1, right? So it's going to be d2 minus 1 amplitude at the top of these parabolas. Again, they're not parabolas, but and then u-shapes we'll call them. And then d plus amplitude, 2 plus 1, give us 3 is at the bottom of these parabolas. So the range is going to be from negative infinity to 1, and then from 3 to infinity, which is verified right here. Okay, now what if we make a negative 4 and d 3? Let's take a look. You'll see that the a value, negative or positive, doesn't matter. D equal to 3. Okay, so the middle of the graph is still at 3, right? So it's going to be 3 minus 4. It's going to be 3 minus the absolute value of this. It's going to give us negative 1 at the right here where the top of these U-shapes, upside down U-shapes are. And then 3, middle of the graph, plus 4, be at the bottom of these U-shapes, 7. Okay, so negative infinity, negative 1, and then 7 to infinity. Don't forget your brackets and your parentheses. So, all that to say, this is the visual proof. Now, this works the same for secant as it does for cosecant. All it really does is just, secant and cosecant are basically just phase shifts of one another. So, the rules apply no matter what. So, the range of both of these functions is going to be parenthesis, negative infinity to comma d minus absolute value of a bracket, comma, bracket d plus absolute value of a comma infinity parenthesis. That's going to be the range for both secant and cosecant. Next, we'll look at a formal proof. But if you have any other questions about these graphs or these visual illustrations, let me know.